Hello viewers, welcome to our channel Career Prep. In this video, we'll learn about a very important topic, data interpretation. Data interpretation questions are a major part of the quantitative aptitude section in all major government competitive exams like SSC, IBPS PO, SBI PO, RRB, insurance, etc. This is one topic where questions from different concepts like ratio, averages, percentage, etc. are included. If the basics of these concepts are clear, attempting data interpretation in the exams becomes comparatively easy. These questions are the ones where marks can be scored easily if practiced well. So understand the concept well. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. First, let's understand what is data and what is data interpretation. So what is data? Data is the collection of numbers, facts, and figures which have some meaning when arranged in a proper manner. The data can be given in the form of tables, graphs, charts, etc. So what is data interpretation? When analysis or interpretation of data is made to draw some inference and conclusion, it is known as data interpretation. Thus, data interpretation is the process of understanding, organizing, and interpreting the given data and getting a meaningful conclusion. The basic concept of data interpretation is to review the collected data by means of analytical methods and arrive at relevant conclusions. You have to follow these steps for interpreting data to solve data interpretation questions. Data interpretation questions are based on information given in tables and graphs. So get a general picture of the information before reading the question. Collect the information you will need to interpret the data. Read the given titles carefully and try to understand its nature. Avoid lengthy calculations. Generally, data interpretation questions do not require extensive calculations and computations. Most questions simply require reading the data correctly and carefully and putting them to use directly with common sense. Use only the information given and answer the questions asked. Apply basic mathematical rules, principles, and formulae to answer the questions. The majority of the questions asked in the data interpretation section are based on ratios, averages, and percentages. So be very clear with the basics of these topics. Finally, be very careful while dealing with units. Let's learn about the different types of data representation. Data can be provided in a number of formats like tables, graphs, and under graphs there are many types. Line graphs or line charts, bar graphs or bar charts, circle graphs or pie charts, cumulative graphs, mixed graphs, radar graphs, and caselets. Let's learn about these formats of data representation in detail. Let's learn in detail about tables. Tables are often used in reports to present a set of numerical facts. They enable the reader to make comparisons and to draw quick conclusions. It's one of the easiest and most accurate ways of presenting data. Tables require much closer reading than graphs or charts and hence are difficult and time consuming to interpret. One of the main purposes of tables is to make complicated information easier to understand. The advantage of presenting data in a table is that one can see the information at a glance. A table is a set of data arranged in rows and columns. A table consists of several boxes with information inside. Let's understand in detail about tables and what a table consists of. A table consists of a title or the heading of the table. The title of the table gives the description of content of the table and often the purpose of the information presented. A table also consists of row titles and column titles. The first row and the first column are generally used to denote the row and column headings. The row and column headings tell you the specific kind of information given in that row or column. A table consists of a body which is nothing but numerical figures. A table also consists of a head note. In general, the unit of measurement is specified in the head note. A table consists of a footnote which gives further explanation of the table or point out any exceptions in arriving at the data. A table may also give the source which gives the authority of the data. Now let's understand all this with this example of a table. Now as you can see, this is the title of the table, breakup of GDP. This title indicates that the numerical values given here in this table with regard to the breakup of GDP. Now a table consists of row titles which indicates the components of the breakup of the GDP. The table also consists of column titles. Here, these column titles indicate the breakup of GDP in particular years. Here it is 1990, here it is 2000. Thus here the row titles indicate the components of the breakup of GDP and the column titles indicate in which year the breakup of figures for the breakup of GDP is given, for which year. Now the body of the table consists of numerical figures. These figures indicates the figures for the breakup of GDP. This is the head note of the table. In the head note we can see that the unit of measurement is specified. That is, it indicates that the numerical figures given in this table are in millions of US dollars. The table also consists of a footnote. This is the footnote. This footnote tells us that in 2000, prices were 1.5 times the price in 1990. Now, using all this information given in the table, you have to answer the given questions. Let's understand in detail about line graphs or line charts. Line graph represents data in the form of straight lines that connect various data values. Line graphs compare two variables. Each variable is plotted along an axis. A line graph has a vertical axis and a horizontal axis. Line graphs are used to show how a quantity changes continuously over a certain time period. If the line goes up, the quantity is increasing. If the line goes down, the quantity is decreasing. If the line is horizontal, the quantity is not changing. Line graphs are especially used by stockbrokers to study the movement of share prices. Line graphs are also used to show the growth of a company or a product, average income and expenses, population, demand and supply, etc. Line graphs are of two types, single line graphs and multiple line graphs. As you can see here, in a single line graph, you will see only a single line plotted in the graph. Whereas in a multiple line graph, you will see more than two lines plotted in the graph. Now let's consider a single line graph. You know that a line graph compares two variables, and each variable is represented on the one in the horizontal axis and the other in the vertical axis. Now consider this line graph. This single line graph is regarding high temperatures in July. So the days in July are plotted along the horizontal axis, and the temperatures in Fahrenheit are plotted along the vertical axis. Now, as you can see here, on day one, the highest temperature in July was 85 degrees Fahrenheit. On day 2 in July, the highest temperature was 90 degrees Fahrenheit. In day 3 in July, the highest temperature was 95 degrees Fahrenheit, and so on. All these data values are joined with a straight line to get a line graph. Now, when a single glance at this line graph will show you that from the first day to the second day, there was an increase in temperature. Again, there was an increase in temperature till day 4. And after day 4, there was a decrease in temperature till day 7. Now, using all this information given in the line graph, questions will be asked to which you have to give the answers. Now, let's consider the multiple line graph. Here you can see two lines are plotted in the graph. Now, this multiple line graph is regarding average daily temperatures. Here, the days of the week are plotted along the horizontal axis, and the temperatures in Fahrenheit is plotted along the vertical axis. Now, this red color line indicates the average high daily temperatures, and the blue line here indicates the average low daily temperatures. Now, as you can see from this multiple line graph, on Mondays, the average low temperature was 70 degrees Fahrenheit, whereas the average high temperature was around 82 degrees Fahrenheit. Similarly, on Wednesdays, the average low temperature was 65 degrees Fahrenheit, whereas average high temperatures was 75 degrees Fahrenheit. Now all these data values are joined using straight lines. So this red line indicates the average high daily temperatures on various days of the week, and this blue line indicates the average daily daily temperatures. Now based on all these information given in the multiple line graph, questions will be asked in the exams for which you have to answer. Now let's learn in detail about bar graphs or bar charts. A bar graph is a pictorial representation of data in the form of bars on a graph. There are two types of bar graphs, horizontal bar graph and vertical bar graph. So this is an example of a this is an example of a vertical bar graph, and this is an example of a horizontal bar graph. The heights and lengths of these bars are proportional to the values of data they represent. The longer the bar, the greater its value. Bar graphs are made up of two axes, x-axis and y-axis. In a vertical bar graph, the x-axis shows the data categories and the y-axis shows the scale. In a horizontal bar graph, the y-axis shows the data categories and x-axis shows the scale. Thus, in a bar graph, one axis represents the categories being compared and the other axis shows the discrete value. The width of the bars is not important. It's only used so that the presentation is clear. Now let's understand all this with examples. So this is an example of a vertical bar chart and this is an example of a horizontal bar chart. As you can see in these charts, data is represented in the form of bars. Here in a vertical bar chart, the bars are vertical, whereas in a horizontal bar chart, the bars are horizontal. The heights and lengths of the bars are proportional to the values of the data they represent. The longer the bar, the greater the value. Now bar graphs are made of two axes, the x-axis and the y-axis. Here this is the x-axis and this is the y-axis. In a vertical bar graph, the x-axis shows the data categories. Here this vertical bar chart is regarding the favorite color of students. So this x-axis shows the various colors, red, yellow, blue, green, etc. And the y-axis shows the scale. Here it is the number of students. Now in this horizontal bar graph, the y-axis shows the data categories, whereas the x-axis shows the scale. Here the y-axis is the shows the different types of fruits, whereas the x-axis shows the number of people who like these fruits. Thus, in a bar graph, one axis represents the categories being compared and the other axis shows the value. Now let's understand vertical uh, bar, vertical bar graph and horizontal bar graph in detail. Look at this vertical bar graph. This bar graph is regarding the favorite color of students. So the different colors are plotted along the x-axis and the number of students who like those colors are plotted along the y-axis. So different colors like red, yellow, blue and green are plotted along the x-axis. Now observe here that scale is given. Scale is 1 unit is 5 students. So don't get confused that these are the total number of students. Instead these indicate the units. So now this red color corresponds with 10 units, not 10 students. Red color corresponds with 10 units. So we know it's given that 1 unit is 5 students. So 10 units will be 50 students. So 50 students like red color. Similarly, yellow color corresponds with 5 units. We know that 1 unit is 5 students. So 5 units is 25 students. So 25 students like yellow color. So this is how you understand the data given in a bar graph. Now using all these information given in the vertical bar graph questions will be asked in the exam to which you have to answer. Now look at this horizontal bar graph. Here, this horizontal bar graph is regarding the nicest fruit. The different fruits are plotted along the y-axis and the number of people who like those fruits are plotted along the x-axis. So the number of people who like apples is 35. Now here, since the scale is not given, this the values that are plotted on the x-axis gives us directly about the number of people. So number of people liking apples is 35. Number of people who like oranges are 30. Similarly, 10 people like bananas, 25 people like kiwi fruits, 40 people like blueberries, and so on. Now, based on all this information given in the horizontal bar graph, questions will be asked in the exam. Now, there are various types of bar charts like simple bar chart, subdivided bar chart or component bar chart, multiple bar chart. Let's learn about these various types of bar charts in detail. Let's now learn about simple bar chart. A simple bar chart is the simplest bar graph of all. A simple bar chart relates to only one continuous variable charted along with one discrete variable. Now let's understand how to interpret a simple bar chart using this example. Now this simple bar chart is regarding school supplies used by students. Now this bar chart has an x-axis and a y-axis. Now the types of school supplies are plotted along the x-axis, whereas the number of supplies are plotted along the y-axis. Now since the scale of the number of supplies is not given, these numbers indicate directly the number of supplies. Now each data regarding the different types of school supplies is shown in a bar graph in the form of bars. Now as you can see from this bar graph, the bar corresponding to the pencil corresponds with the number 8. This shows that 8 types of pencils are used by the students. Now the bar which represents the scale corresponds with the number 3. This shows that 3 types of scale are used by the students. Now the bar which represents pen corresponds to the number 2. This shows that 2 types of pens are used by the students. Similarly, the bar representing sharpeners corresponds with the number 5, which shows that 5 types of sharpeners are used by the students. And finally, the bar representing erasers corresponds with the number 4, which shows that 4 types of erasers are used by the students. Now, based on all this information given in the bar chart, questions will be asked in the exam to which you have to answer. Now let's learn about subdivided bar chart. A subdivided bar chart is used to represent the breakup of some continuous variable. Such a use of bar charts is quite convenient for comparing two or more sets of data. Let's understand how to interpret a subdivided bar chart using this example. This subdivided bar chart tells us about the number of students studying in commerce, science and arts in various years. Now, in this subdivided bar chart, the number of students studying commerce is represented by green color, and number of students studying science is represented by brown color, and number of students studying arts is represented by blue color. Now here the year is plotted along the x-axis, whereas the number of students is plotted along the y-axis. Now observe a major difference between the simple bar chart and subdivided bar chart. In a simple bar chart, this whole bar represented one variable, whereas in a subdivided bar chart, this bar represents the breakup of a single variable. Here, this breakup is regarding the students studying in commerce, science and arts. Now, observing this bar graph, you can easily know how many students were studying commerce, science and arts in 2009, 2010, 2011. Let's take the example of the year 2009. This blue color represents the number of students studying arts. So clearly from this bar chart, you can see that the number of students who were studying arts in 2009 corresponds with the number 50 here. So there were 50 students studying arts in 2009. Now this brown color indicates the number of students studying science in the year 2009. Now don't make the mistake of assuming that since this brown color ends at the number 250, there are 250 students studying science in the year 2009. No, that is wrong, because you can see here that the brown color starts from this point, which corresponds to the number 50, and it ends at this point, which corresponds to the number 250. So the number of students studying science is 250 minus 50, that is 200. So 200 students were studying science in the year 2009. Similarly, green color represents the number of students studying commerce. This starts from the number 250 here and ends at the number 350 here. So the number of students studying commerce in 2009 is 350 minus 250, that is 100. So 100 students were studying commerce in the year 2009. Similarly, in 2010, the number of students studying arts is 75, because this corresponds to 75 on the y-axis. Number of students studying science in 2010 is 325 minus 75, that is 250. So 250 students were studying science in the year 2010. Similarly, the number of students studying commerce in the year 2010 is 425 minus 325, which is 100. So 100 students were studying commerce in the year 2010. This is the way to interpret the data given in a subdivided bar chart. Now questions will be asked in the exam based on all this information given in the subdivided bar chart. Let's learn about multiple bar chart. If two or more sets of continuous variables are to be shown on the same bar chart, a multiple bar chart is used. In this type, two or more bars are constructed adjoining each other to represent multiple variables. Now let's understand how to interpret the data given in a multiple bar chart using this example. Now this multiple bar chart is regarding the population rate in millions in various countries during the year 1980, 1990 and 2000. Now the different countries are plotted along the x-axis here, and the population rate in millions is plotted along the y-axis here. Now it's also given that the red color bar indicates the population rate in 1980. The blue color bar indicates the population rate in 1990, and the purple color bar indicates the population rate in the year 2000. Now, as you can see in this multiple bar chart, for each country, the three different bars are constructed adjoining each other to represent uh, the population chart of a chart in the year 1980, 1990 and 2000. Now let's consider the example of France. Here this red bar represents the population rate in 1980. The blue bar represents the population rate in 1990, and the purple bar represents the population rate in the year 2000. Now, as you can see, the population in France in 1980 corresponds to the number 55 here, that is 55 million. So there were 55 million people in France in 1980. Now this blue bar, which represents the population rate in 1990, corresponds to the number 58 here. That is, there were 58 million people in France in the year 1990. Now this purple bar represents the number of people in France in the year 2000, and this purple bar corresponds to the number 65 here, which means there were 65 million people in France in the year 2000. Same is the case for United Kingdom, Mexico, Nigeria and Pakistan. The red color bar represents the population during the year 1980. The blue color bar represents the population in the year 1990, and the purple color bar represents the population in the year 2000. Now questions are asked in exams using all this data given in the multiple bar chart. Now let's learn about bar charts that show deviation. Bar charts are also used to show deviation. Deviation charts show the deficit as well as the surplus, imports and exports, etc. It represents the positive as well as the negative values of the continuous variables. Now this is an example of the bar chart that shows deviation. As seen here, first a baseline is drawn and the positive values are shown above the baseline, and while the negative values are shown below the baseline. So positive values are shown above the baseline, whereas the negative values are shown below the baseline. Supposing this is a bar chart which shows the surplus and deficit data, then the surplus data will be shown above the baseline in the bar chart, whereas the deficit data will be shown below the baseline in the bar chart. Now, based on all the information given in this bar chart, questions will be asked in the exam. Now, let's learn in detail about pie charts. Pie charts are often used in the corporate world and in newspapers. In pie charts, the data is represented in the form of a circle. In a pie chart, a circle is divided into various segments such that each segment represents a certain percentage of the total. Thus, the pie chart is used to show the breakup of one continuous variable into its component parts. Now, this is an example of a pie chart. This pie chart shows how much water we use for different activities. Now, as you can see here in this pie chart, the data is represented in the form of a circle. And this circle is divided into various segments, and each segment shows how much water we use for the different activities. Thus, this pie chart shows the breakup of the continuous variable into its component parts. Now, each segment represents a certain percentage of the total. That is, these percentages show how much of the total we are using for the different activities. When all these percentages are added, it should total up to 100%. Now, although in terms of versatility of data representation, pie charts are less versatile than bar charts, line graphs, or tables, but their utility is in the fact that the representation of the data is cleaner and it gives an immediate idea of the relative distribution of the variable amongst different segments. In a pie chart, the total quantity is distributed over a total angle of 360 degrees. So, this 360 degrees represents 100% of the value of the continuous variable. Thus, in a pie chart, the various components of the continuous variable are represented by the segments of the circle, and the whole circle represents the sum of the values of all the components. Now look at this pie chart. Here, the various components of the variable are represented by the segments of the circle. Now, the total quantity here is distributed over a total angle of 360 degrees. That is, if each of these segments has a value of some degrees, then the total of all these degrees will be 360 degrees. Now, supposing the value of each of these segments is given in percentages, then we know that the sum of all these percentages will be 100%. So 360 degrees is equal to 100%. Now in problems on pie charts, sometimes you are asked to find the central angle. So what is meant by central angle? Central angle is the angle formed by two arms and having the vertex at the center of the circle. Now supposing you consider this segment. Here the central angle is 45 degrees. Now this 45 degrees is formed by the two arms and these have the vertex at the center of the circle. Now this central angle can be found out using this formula. Central angle for a component is equal to value of the component divided by sum of the values of all the components multiplied by 360 degrees. Now in a pie chart, the central angle for any segment can be found out if the percentage value of that particular segment is given. Supposing the value of a particular segment is 10%. You know that sum of the values of all the segments is 100%. So if you can find the central angle for that particular segment using this formula. So central angle for that particular segment is equal to 10% divided by 100% multiplied by 360 degrees, which gives the value as 36 degrees. So if the value of the component of that segment is 10%, then the central angle for that segment is 36 degrees. So if the value of any segment is given in percentage form, then you can find the central angle for that segment using this formula. Now let's learn about cumulative graphs. Cumulative means how much so far. To have cumulative totals, just add up the values as you go. Cumulative graphs are plotted for each cumulative total. Let's look at this example. Charles has earned this much in the last 6 months. So Charles has earned, in March he has earned $120. So the cumulative total is $120. In April he has earned $50 and the cumulative total is 120 plus 50, which is $170. In May he earned $110. So the cumulative total is 170 plus 110, which is $280, and so on. Now to make cumulative graphs, just plot each cumulative total. So cumulative graphs can be represented in the form of a bar graph or a line graph. Look at this bar graph which represent the cumulative total. Now here the months are plotted along the x-axis and the cumulative totals are plotted along the y-axis. So we know that in March the cumulative total is 120. So this bar represents $120. In April, the cumulative total is $170. So this bar for April corresponds to $170. In May, the cumulative total is $280. So this bar for May corresponds with $280 and so on. Now let's look at the line graph. Here the months are plotted along the x-axis and the cumulative totals are plotted along the y-axis. Now in March the cumulative total is 120 degrees. So in March 120 degrees is here. $120 is here. In April the cumulative total is $170. So in April $170 is this point. In May the cumulative total is $280. So in May the $280 is at this point. Now all these points are connected with straight lines to get a line graph. Thus cumulative graphs are plotted either as bar graph or as line graph. Let's learn about mixed graphs. Mixed graphs are nothing but a combination of two or more graphs. In a mixed graph, a combination of two or more graphs is given and one has to correlate the data from these graphs. Now here is an example for a mixed graph. Here this mixed graph contains a table and a bar graph. Now this table gives us information about the number of branches in each year in the different states. So in 2002, the total number of branches is 23. In 2003, the total number of branches is 47 plus 10, that is 57. Also, for each year, the number of branches in particular states is also given. That is, in Andhra Pradesh, there were 23 branches in 2002. In 2003, it is 47 and so on. Now coming to the bar graph, this bar graph uh, shows us the deposits in crore rupees and loan advances in crore rupees by the banks from 2002 to 2007. The green color indicates deposits and the brown color indicates loan advances. As you can see, in 2002, the deposits by the banks is 50,000 crores. In 2002, the loan advances by the banks is 30,000 crores. Now, based on all this information, questions will be asked in the competitive exams on mixed graph. You have to correlate the data from both these graphs to answer those questions. Let's learn more about radar graph. A radar graph, also sometimes called a spider graph or a spider chart, has its zero starting point in the middle. From the middle, each axis of the chart can protrude out like the spokes on a wheel. There can be one axis for each subject and there is no limit on the number of subjects that can be used. When these axes are linked, it divides the entire graph into different grids that help us to represent the information in a better way. Various values are plotted on each axis. The data values increase the further away you get from the zero center of the radar graph. Now look at this example of a radar graph which shows the sales of various products throughout the year. Now let's understand how to interpret this radar graph. Now as you can see here, this radar graph has its zero starting point in the center, and from this center axes protrude out in the chart. And here in this particular radar graph, each axis represents a month. Now when these axes are linked, the entire graph is divided into different grids. Now various values are plotted on each axis. Now if this is 0, then this is 50, this is 100, this is 150 and this is 200. Now as you can see here, as you move away from the zero starting point, the values start increasing. So now in this particular radar graph, blue color shows the number of TVs sold in that year, in that particular month. The brown color shows the number of smartphones sold. Green color shows the number of computers sold. Now, as you can see here, this axis represents January month and blue color represents the number of TVs sold. So as you can see here, uh, 55 TVs are sold in the month of January. Now brown color shows the number of smartphones sold. Now supposing you consider the month of May, then you can clearly see that 150 smartphones are sold in the month of May because this point represents 150. Now green color shows the number of computers sold. Supposing you consider the month of September, as you can see in September, the September 25 computers are sold. Now based on all this information given in the radar graph, questions will be asked in the competitive exams. You have to understand and interpret this radar graph to answer those questions. Let's now understand in detail about caselets. In caselets, the mathematical data is represented in the form of a paragraph. Hence, extracting data and establishing relationships between different data values becomes difficult. So to solve the questions, follow these steps. Understand the subject matter of the passage given. Be clear on what is given and what is asked. Underline all the important points in a caselet while reading it. Use symbols in place of names of persons, places, etc. to make your work easier. Try to represent the data given in graphical or tabular form. Read the figures closely. You can use the options and approximations to avoid lengthy calculations. Here are a few formulae and concepts which will help you to solve data interpretation problems. Now, most of the data interpretation problems are based on ratios, averages, percentages, simple and compound interest, profit and loss, etc. So remember all these formulae and concepts which will help you to solve data interpretation problems easily. Now you know that a ratio is represented as A is to B. This is nothing but A divided by B. Now if a ratio is A is to B, then the values will be AX and BX. Now let's move on to average. Average is nothing but sum of all the items divided by number of items. Let's learn a few formulae on simple interest. Simple interest is equal to principal multiplied by rate of interest multiplied by time divided by 100. Now simple interest plus principal is the total amount. Let's move on to compound interest. Now the interest for the first year is nothing but simple interest. Now the amount at the end of the first year is the principal for the first year plus the interest. Now this amount is the principal for the second year. Hence, for every changing year, the principal changes and accordingly interest also changes every year. Since principal increases every year, Compound interest is always more than the simple interest. Now, compound interest can be calculated using this formula. Compound interest is equal to principal multiplied by 1 plus r by 100 raised to the power of t minus 1. Now let's move on to percentages. If you are asked to find A is what percent of B, then divide A by B and multiply with 100. If you are asked to find what is A percent of B, then divide A by 100 and multiply with B. If you are asked to find percentage change, then use this formula. Percentage change is equal to new value minus original value divided by original value multiplied by 100. If the answer is positive, then it is a percentage increase. If the answer is negative, then it's a percentage decrease. Now, if A is increased by k percent, then the new number is A plus k percent of A, or 100 plus k divided by 100 multiplied by A. If A is decreased by k percent, then the new number is A minus k percent of A, or 100 minus k divided by 100 multiplied by A. If you are asked to find A is how much percent greater than B, then find the difference between A and B and divide that with B and then multiply by 100. Multiply with 100. Now remember that the value given after the word than should be in the denominator. If you are asked to find A is how much percent less than B, then find the difference between A and B and divide it with B and then multiply with 100. Remember that always put the value that comes after the word than in the denominator. Here are a few formulae on profit and loss. Profit or gain is equal to selling price minus cost price. Loss is equal to cost price minus selling price. Gain percentage is equal to gain multiplied by 100 divided by cost price. Loss percentage is equal to loss multiplied by 100 divided by cost price. Marked price minus amount of discount is equal to selling price. Marked price multiplied by 1 minus percent discount is equal to selling price. Selling price is equal to cost price multiplied by 1 plus percent gain. Viewers, please go through this video till you have understood the concept. Please do watch all our videos on solved problems on data interpretation of various types of data representation for better understanding. Also do watch our videos on ratio, averages, percentage, profit and loss, simple interest, compound interest, etc. for a thorough understanding of the topics, which will make it easier for you to solve data interpretation problems. If you have liked this video, please like, subscribe and share this video. Thank you.